your stuff. Okay. Are you ready? Same does. Okay, so you're going to pick which of those compounds would be the choice for number 2 to make that compound on the right from the compound on the left. Can you see the structures good enough? I mean, I feel like they're not very dark. When I paste into there, it just, this program doesn't pasting. All right, I've got 17. I got one more. So somebody make a guess. A guess is better than no answer. Agree? Agree. I gave you so many good choices. All right, so what happens when you do the magnesium? What does it do? It goes where? BR. Between the Br and the carbon. That makes this carbon into a, what kind of carbon? A nucleophile, right? Okay, so where are these pieces? How many carbons are there? 1, 2, 3, 4, 5. Where are those 5 carbons over there? 2, 3, 4, 5. Okay, so this is the piece that we're going to put in. Okay, agree? The carbon that's attached to the OH, where does it come from in the compound that you add to? That you add to a Grignard. Where does the carbon that's attached to the OH, where does it come from? See what? Okay, it comes from the carbonyl compound, right? We're going to go like this out to the O. And then we're going to protonate with our little acid, H3O+. Okay, so which one is it? Well, we need a benzene, that's the pH, and then we need a CH2, and then we need a C double bond O. So which one is it? That makes sense? Okay, do you see why it's not A? Okay, A has the correct number of carbons. If you did it that way, that's not a bad way to approach it from. That should have narrowed it down for you. But if you have A, okay, that's A. Remember that that's what the parentheses around the O means. Okay, this would go to here, go out to the O, and you get protonated. So you're going to get 1, 2, 3, 4, 5. See how this is different from this, how the carbons are hooked together, okay? Okay, so we're going to reduce carbonyls to make alcohols. Remember that oxidation is loss of hydrogen or addition of oxygen, and reduction is addition of hydrogen or loss of oxygen. So if we're going to reduce carbonyls, basically what we're going to be doing is adding hydrogen to them. Okay, when we add hydrogens to them, we can make primary or secondary alcohols. We can't make tertiary alcohols using a reduction method like this. Okay, typically we use hydride reducing agents. There are two main ones that have been used for a long time: sodium borohydride and lithium aluminumhydride. They're very similar. Sodium and lithium are near each other on the periodic table, and so are boron. Okay. In these complexes, hydride gets transferred from them to the carbon of the carbonyl. Okay, so what's hydra? Hydrogen is H. What's this? What is our shorthand for H plus? We say a proton, okay? Because we have 1 proton and 0 electrons. Regular hydrogen has 1 proton and 1 electron. Okay, what is hydride? Well, if something ends with "ide," it typically has what charge? Hydroxide, fluoride, negative. Okay, this is an H with a negative charge. That's hydride. Did you ever have to draw structures for sodium hydride, NaH? Remember, hydrogen sometimes gets put in the middle of the periodic table because it can gain an electron and go to the right, or it can lose an electron and be on the left. So it can be positive or negative. It only has 1 to start with, 1 electron. So hydride has 1 proton and 2 electrons. And sometimes it gets written like that with the lone pair. Okay, but that's hydride. Okay, so all these things are going to transfer an H minus to your carbonyl compound. Remember, your carbonyl is polarized. The okay, how's it polarized? The carbon end is, oh, yeah. So this is delta plus, this is delta minus. So if you're H minus, where do you go? You're going to end up here. Okay? All right, so the hydride attacks the carbon of the carbonyl to form an alkoxide ion. So you're going to go out to the O. Notice, every time we attack a carbonyl, we go out to the O. Okay? Every time. All right, so here's our alkoxide ion. And then there is another step. Either you add a simple alcohol or you add water. You could even add actual acid. Now, how come the water gets to protonate this time? I just told you, water didn't protonate. The other thing, sulfuric acid did, because this is a strong base. So water being a weak acid, it's enough to do it. Okay, that's the difference. The O is negative, not neutral. Okay. All right, so you can add a simple alcohol like methanol or ethanol. I don't think I have that on that slide, but you can. Okay, I've done it that way, personally. Okay. Sodium borohydride, lithium aluminum hydride, they all react the same way. it's important that you know where the hydrogens are coming from. So this hydrogen right here, the one that's attached to the carbon, came from the reagent, okay? This hydrogen here that's attached to the oxygen, where did it come from in the mechanism? It came from the water, okay? Sodium borohydride gets used to reduce aldehydes to primary alcohols or ketones to secondary. Okay, so this is an aldehyde example. Okay, that hydrogen is this one. Okay, where did the hydrogen up here come from? Where do you think? It didn't come from the sodium borohydride. Yeah, it came from here. The hydrogen attached to the O on that little alcohol. Okay, some of these can be done actually in the alcohol. So like you could use ethanol as your solvent when you do sodium borohydride. When you do lithium aluminum hydride, it's much more sensitive to water and you can't have any water in it. Ethanol is the alcohol that you can drink. If you are over 21 and you do so in moderation, don't drink and drive, okay? But that alcohol, as soon as you open, like if you have 200 proof ethanol, that means it's 100%. Y'all know that, right? The proof is double the percent. Just checking. It's amazing the things you do know that I'm like, they know that? Sign. You know all about alcohol, right? Okay, so when you open that bottle of 200 proof alcohol, what happens is it immediately starts pulling water out of the ass. It is no longer 200 proof alcohol. So if you need to use it in a reaction and it has to be dry, you're probably going to have to distill it, and well, you can't distill it. You're going to have to keep it dry. If somebody tells you that they made 200 proof alcohol, you can't make it by normal. Like if you take yeast and you make alcohol, okay, like a distill or something, and then you distill it over, the best you can get is 95. And that's only if you are a really good distiller. Most people get 85 to 90. Okay, we've done it in lab, so I know what y'all can get. And that's with real distillation equipment. Okay, people who make moonshine don't have real equipment. They have funky that they put together, right? So anyway, so you can't get better than 95 by distilling. Why? You heard of something called an intro? What are those? So you didn't talk about them when you did distillation last semester in lab? Your first? You did? Yeah. They're when two things distill over at the same temperature and they don't separate like they should. Well, because water and ethanol are so miscible in each other, they will distill over and you can't get better than 95. Okay, so if someone tells you that, you have to say, okay, so what do we do? Because in order to get, we can buy 100% alcohol because we need it for reaction stuff. We have alcohol places. We get alcohol. Yeah, no, well, not like we're selling it or nothing. But so let me tell you, I can spike the punch. So, but when they do that, what they do is they put it through some other columns that have drying agents there, and that's how they get that water out. The last 5. Okay, so just, but it's really tough to keep it dry. Okay. Here's lithium aluminum hydride. This will reduce ketones and aldehydes plus carboxylic acids and esters. Okay, the sodium borohydride will not reduce these guys, the carboxylic acids and the esters. Okay, so you see what this little chart is over here? Lithium aluminum hydride reduces these in addition to the aldehydes and the ketones. So what do you get? Well, what you would end up getting from the ester would be a primary alcohol and whatever the other alcohol is. You would have to clean it up and separate them if you, oh, it's not going to let me write it. Okay, this one you just get RCH2. Okay, but sodium borohydride won't do that. So if you have both things in one compound, you can pick how you want to reduce them to some degree. Off the top of my head, I don't know a way to reduce just an ester and not the other two. These are harder to reduce. Typically, lithium aluminum hydride is considered the more reactive of the two reducing agents. All right, so up here, those little pictures weren't supposed to be there. Okay, so. Oh, too funny. There needs to be a way. Okay, so like here we have a ketone, and we're going to use sodium borohydride and methanol. And so 1H is going to go here, 1H is going to go here, and what happens to the double bond? It's gone, right? Don't leave a double bond there. Your carbon will have too many bonds. Okay, so look at this one. This one has a ketone over here and an ester over here. Agree? Okay, so the sodium borohydride will only reduce the ketone. Okay, the ester doesn't get reduced. Okay, if you use the same compound with lithium aluminum hydride, they're both going to get reduced. Okay, so you see the difference? For this one up here, the top one, it wouldn't matter which reagent you pick. Okay, just like some of the other things, there's going to be multiple correct answers sometimes. Okay, lithium aluminum hydride and water are incompatible. LAH is a shorthand that gets used for lithium aluminum hydride. You probably think LiAlH4 is short enough, but I don't know. I see it in journals and all kinds of stuff. And water are incompatible. So the water is added in a separate hydrolysis step. Okay? An explosion and fire would result from LaH plus H3O plus. So hence we try to avoid those things. Okay? You seeing the differences? Okay. So here's a chart that kind of is listing all the possibilities. So we've got an aldehyde with sodium borohydride and lithium aluminum hydride. Either one, you get the primary alcohol. Ketone, you get the secondary alcohol. An alkene, look at this. What does no reaction mean? It leaves it alone. Okay, so if you had, okay, here, I'll do this. Okay, so if you had this compound, what would you get? You have this compound and you add sodium borohydride and methanol. Well, what's going to happen to the ketone? It's going to become a alcohol. What about the double bond? Nothing. Nothing. Nothing, honey. Okay? The double bond is still going to be there. Okay? That's what, when we say this. Okay, now, if you had an acid anion, so a lot of times they'll take the carboxylic acids and they'll make it a basic. I'm not like super picky about that. But this one is no reaction. This one reacts. And here's your little ester. This one reacts. Okay. The products shown are the final products after hydrolysis of the alkoxide. Okay, so even if you did this thing on the bottom here with lithium aluminum hydride, you would still get the same. Okay, neither one of them react with double bonds. We're going somewhere? Why do I have a blank page? Okay. All right, let's just do that. And then I'll, gonna work. What are you gonna get? You might have to kind of decipher them. When they draw them all in one line, I think sometimes it's harder to see. It's easier to just draw the picture. Not taking you? Oh, she wants to clean it. I gotta do what she's doing. Going to 18, right? 18's the number. Okay. Okay, so we have an alkene, right? What is this? A ketone. What's this? Carboxylic acid. Too long. Okay, so we're using sodium borohydride. So what do we reduce? Only the ketone. Everything else is going to remain the same. So it's okay. You with me? Okay. I'm going to add a slide because I'm wanting something. I keep wanting to tell you about something and it's not here. All right, look at this compound. Okay, we're going to reduce that and we're going to use this. Instead of sodium borohydride, we're going to use NaBD4. What's D? Deuterium, okay? So you remember what deuterium is? Besides D. What is that? What is it? It ain't on the periodic table, is it? It's hydrogen with what? It has something. A neutron. One neutron. Sometimes it's referred to as heavy hydrogen. Okay. Okay, so I'm going to use that, and then I'm going to just have H2O. What am I going to get? Confusion? I already got that. Where did the hydrogen that was on this, where did it go? In the what kind of, if it just said NaBH4 and H2O, what would you make? You don't know? You would make a secondary alcohol, right? Okay, those were the two hydrogens that got added in our little reduction, okay? But we changed one of them from hydrogen to deuterium. Where does the deuterium end up in the product? You got a 50-50 on the carbon. It's going to be right here is where the D is. Okay, look here. What if I used NaBH4 and instead of using water, I used D2O? What would I get? Yep. I think that's called an optometrist. Isn't that an OD? So my hydrogen is going to come from the Borohydride, and then the D2O supplies that one. That's why you need to know where they come from. Okay, it's a pretty straightforward, simplistic mechanism, but you need to know where each hydrogen comes from. Okay, what if, there's one more case, we did it with that? What would you get? O, D, and D. You get D's in both spots. Okay, now what is the whole point of this? Well, the whole point of this is that sometimes someone's studying a molecule and they're trying to figure out, where does it go in the body? Where does it build up? How does it get metabolized? And one of the things we do is we label things. So we would put a deuterium in a specific spot and then figure out where it came out in the end. Okay? Did it just collect in the liver and kill the rat, you know? Did it go to their brain and just hibernate? Or did they just pee it out? You know, I mean, they really, literally go through and figure out where it goes. Okay, and that's part of how they study the metabolism of drugs, is by doing these labeling things. Okay, so you want to be able to label things in specific spots. This is just one thing that you could label. You can label other things, okay, other elements and stuff like that. This is just one, okay? That's why we do that. Okay, so I'm going to tell you about Raney Nickel. Raney Nickel is a heterogeneous catalyst that was developed by a fella named Raney. I love it when you get that. Okay, and nickel is the basis for the catalyst. There's aluminum and some other stuff in there, but I'm not really worried that you know that. You can just learn the words Raney Nickel, kind of like you learned Lindlar catalyst. Okay? Only, what does Lindlar catalyst do? It makes what? Cis double bonds from alkynes. Okay, you got to keep all that, yeah, the cis. If you want trains, you got to do something else. All right, so Raney Nickel gets used to add half-add hydrogen across the carbonyl. Okay, because you can actually hydrogenate a carbonyl just like we did the double bonds. Okay, there are other reagents that can be used, and Raney Nickel can be used for other things as well. I actually used Raney Nickel in graduate school for other things. Okay, it has to do with sulfur. I did a bunch of sulfur stuff. I was the stinky one. Well, when you make Raney Nickel, you actually buy the catalyst, but then you have to infuse it with the hydrogen. Okay, so what do y'all know about hydrogen? It's what? It's flammable, right? Okay, it's flammable. Okay, so you have to be careful when you make Raney Nickel. You mix all this stuff together, and then you have to suction filter. Okay, so why do we suction filter in the lab? Because what does it do to our crystals? It helps to get them very dry, okay? If you let the Raney Nickel catalyst infused with the hydrogen get dry, it will light on fire. So when you get to the filtering part, and I know this from experience, you have to filter it and keep it wet. Ever tried to do that? So we're suction filtering. You literally have gobs of methanol there because you have to rinse all that extra base and stuff out of there that used to put the hydrogen there. And so you're just kind of keep dumping it in. It'll start to get a little bit dry, and y'all, little flames start popping up in your little Buchner funnel. It's kind of exciting and nerve-wracking and panicking all at the same time. So yeah. So anyway, you have to dump the methanol on there. And so you know how you have that track with that little deal? Okay? one of the reasons that little deal is there is so you can easily release the suction. Okay, so you have to, after you get it rinsed with a bunch, and of course you're using a very large filter glass because you don't want that to fill up while you're dumping all that methanol on there, and then you release that, and then you can take it moist and quick dump it into your reaction mixture or whatever you're gonna. Okay. Yeah, I just dumped it in. Yeah, we used excess. That way I didn't, you couldn't weigh it out, right? Okay. Well, the thing with Raney Nickel is it will reduce your carbonyl to your alcohol, okay? It does not reduce a carbonyl in an ester or a carboxylic acid, but it does reduce double bonds, okay? So you're gonna reduce carbonyls and double bonds. It would also reduce triple bonds. Most people don't do that, but yeah, it's hard enough to deal with that triple bond. So look at this compound up here. We're going to take this and we're going to add hydrogen and Raney nickel, okay? And when you do that, here's your double bond. It gets reduced. Here's your aldehyde. It gets reduced, okay? In contrast, if you use sodium borohydride and methanol, only the alcohol would be formed. You wouldn't reduce the double bond. Okay? And if you use a different catalyst, you could reduce only the double bond and not carbonyl. So you kind of can do like almost everything. Okay? For whatever reason, your book didn't tell you about that. But like if you took this and you used hydrogen and just plain old platinum, you'd probably get 1, 2, 3. You could get this. It's not like it's the easiest thing to do, okay? Hydrogenation is a pain, okay, to do. Especially the regular one, because you have to pump the hydrogen in and you have to shake it, and your catalyst is heterogeneous, and it's highly nerve-wracking. And we had a special room that we would do them in called the bomb room, okay? Because it was made that if the hydrogen blew up, okay, that the room would implode rather than explode. Okay, so only whatever is in that little room, which isn't very much, and you would die. Okay, but otherwise, so typically what you would do, literally, is you would get it started, you would literally run out. Yeah, I hated working with hydrogen. It's pretty nerve-wracking, yeah. And then, when you decide the time is up, you have to go back in and turn it off. There were a couple of deaths in there. Like when you're a graduate student, one of the things that they do is they pay you to teach the undergraduate labs at the school that you're at. And at most schools now, you don't have to pay tuition either. Okay, so if you don't know what to do, you want to consider graduate school, go talk to the schools. I had to pay tuition, but that was a few years back, just a couple. And when I went, but they gave me in-state tuition. It's also a chance to go out of state. So I went from Illinois to New Mexico for graduate school. Got to go to a whole new place, met my husband, and I ended up here. Oh my God. But it's a chance to do some of those things that you might have thought you didn't have a chance to do. It's like nobody hardly told me anything. I figured everything out on my own. But anyway, they pay you to go to school and teach those labs, and it's like, and you're getting your degree. It's like, oh my gosh, my first paycheck, it was like, this is the most money I've ever made in my life. I can barely pay my bills, but by golly, it was still the most money I ever made. So you got to start somewhere. But anyway, yeah, it's graduate school is a whole nother ballgame. If you're considering graduate school in any area of science, they want you. They want you to come help with the labs. They want you to come and do the, take the classes and do good, okay? We used to say it was easier to get into graduate school and harder to get out. it was harder to get into medical school and easier to get out. Because if you get into medical school, they have invested in you, and they will really try to help you finish, even if you have to repeat a year, which of course none of us do. But they'll help you get out. Although we have, over my 30 years of being here, we have had a couple students that didn't make it. They weren't on my top 10 anyway, so. My top 10s have always made it, yeah. So, like every once in a while, you're surprised that somebody got in. You're like, really? Oh, I hope they did. Yeah, you know, they don't. But only like two. Only like two over the years. I think everybody's made it through pharmacy school, dental school, PA, all the schools. The only ones that we've had a couple issues with have been a couple months. But otherwise, y'all did good from here. All right, you ready? So what are you going to get from this one? You got to keep all of those things in line. In mind. Keep all those things in mind, all the different specificities. It's not. In grade school, they don't care, they keep you down. Yeah, I came in with, I want to say there was 8 of us, 8 to 10 of us in our class, and half of them left. They either left, they didn't make their grades because you have to have a 3.0, or you get put on probation, or they just said, I don't want to do this, and left. You know, it's like half of us left. And did y'all know that you can skip your master's and just get your PhD? You don't have to get a master's. That's another thing you need to know too. So things to think about. You can start, you know, work on your master's and then go, I think I will go all the way. Graduate school is more determination than anything. You got to be determined that you're going to get through it. And I had to put up with a department that had like 20 professors and only 1 woman in it. And some of the guys would pick on girls. Yeah. It's changed a lot. I don't think they could get away with it now. Thank the Lord. All right, we're ready? I talked all the way through that. Okay, so you're going to reduce the ketone to the alcohol and the carboxylic acid to the alcohol. Okay, make sure that you notice that. Okay, there's 2 carbons. There's 2 carbons. Okay, this carbon, I'll put the arrow, is this one. And this does not get reduced. Okay, so you got it? Yeah. Any other? I thought somebody raised their hand. Okay. Okay, now what happens if you do this one? We'll see if you got anything out of place today besides the fires. You just got to read it, show. I try to check. All right, we're all up there. Okay, Raney Nickel is going to reduce the ketone. Yeah, it isn't an aldehyde in here. Okay, what else is it going to reduce? The double bond. Is it going to reduce the carboxylic acid? No. So the answer is no, it's C. No, it's B. God. Okay. Do we have anything else left in this chapter? Oh, okay. The thiols. Okay. Oh, the big thing about thiols is that they stink. Did you know that? SH compounds stink. Pure sulfur, y'all, does not stink. So if you have a jar of pure, I'm like, they had to prove it to me. I had to go to the stockroom and open the bottle of pure sulfur, go, doesn't stink. So it has to do with it being oxidized to different oxidation states. That's why it stinks. Okay. Okay. Thiols are often referred to as mercaptans. That's kind of an old term that gets used, kind of like olefin gets used for alkenes. It's an old term. Okay. Typically, if thiol is your compound that you're naming, you would say thiol is your ending instead of OL. If it's an alcohol, it's OL. This would be thiol, would be the whole ending. So right here, this compound is butane 1-thiol. Okay, I'm not going to do a big thing on naming because it's not worth it. I mean, you're going to, if you run into it or study it. The group name is mercapto. What you're going to find out as we start adding on more functional groups is that alcohols don't always win and other things beat them. And so they get named hydroxy and an SH gets named. And you may run across this depending on what you're looking at. I want to show you skunks and natural gas. Pure natural gas does not have an odor. Okay, what they do is they add compounds to it to give it an odor. If you have a house and you have propane, a propane tank, they add stuff to your propane tank. That will get used up over time. Make sure that you get it replenished. They should, when they fill your propane tank for you, they should be checking that and making sure. It's a safety issue. Natural gas has a specific odor, okay? That is from ethane thiol. So what is that? CH3, CH2. Okay? This is what is the skunks. Okay? Is those two compounds. Very different from ethane thiol. Would you not agree? In case you've ever smelled this stuff. Okay. Hey. Alexis Burgess. Lindsay. Brianna. Jeremy. Lakeland. Who's in the back? Augusta. Brandon. Taylor. Andrea. Benicia. Kaylee. Glenna. Oh, you're right there. Oh, you're hiding back there. Morgan. Stacy. Tyler Ramirez. Taylor and Tyler. Alexis. Caitlin. Yes, I'm off first. Oh. Okay, so what did you do about being sick? Oh, okay, cool. All right, that works. Thank you. Hopefully that'll be it, right? Yeah. Oh. It's going to be this little black thing again. Oh, and then it heard me saying all your names. I feel like that's kind of not. What? Two things. Okay.
One, chapter 9, I thought I finished it, and then I looked at it. I really thought I had finished it. I didn't think.
Well,
that,
it's supposed to automatically.
I only got 7 out of 29, so evidently I did, but I thought I. So it's my mistake. If it's not, if I can't open it back up, I'll just do my best.
I can do it one time. How
Okay.
about that?
And then the second thing is I just got a email back from the Noble Foundation.
Yay!
So they're asking me